Now, this is kind of terminology of what we see. Now, a system of linear equations is called consistent if it has one or more solutions, and inconsistent if it has no solutions. Okay, so those are one way to talk about solutions as consistent versus inconsistent. Furthermore, if we go even more detail, consistent system is said to be independent if it has exactly one solution, often referred to as the unique solution, and it's dependent if it has more than one solution. So more than one solution would be two lines that coincide on top of each other. Okay. And exactly one solution would be two lines that have an intersection. So that would be exactly one solution. That would be an infinite number of solutions. Now, two systems of equations are equivalent if they have the same solution set. Okay, so that's another word that we use here. Now, possible solutions to linear systems. So, again, we have some ax plus by equals h and cx plus dy equals k. And so it has exactly one solution. It's going to be consistent and independent. If it has no solutions, it's inconsistent. And if it has infinitely many solutions, it's consistent and dependent. And there's no other possibility. So these are the possible ways that we can write our solutions. It's consistent and independent, inconsistent, or consistent and dependent. All right, so here we're supposed to use a graphing calculator and a graphing approximation technique to solve the system to two decimal places. Now that the key here is you have to use a calculator to be able to get it to two decimal places. So what we're going to do is we're going to plug both of those in and solve for y on both of them because we have to plug that into our calculator in that manner. So we're going to get, that one and that. And so we have those two equations. And we plug those into our calculator. So we go up to the y1, plug it into the first one, and we plug in the first equation, plug in the second equation, and then we have the two equations. And if your calculator is luckily one that has color, the red one is the 2/3 x, the black one is, or the blue one rather, is the negative 2.5x. So it'll kind of tell you which one is which. But you should be able to know that. Now, to figure out what is that intersection point, what we're going to do is once we're in here, we're going to hit basically second trace, and then we'll hit number five, and then we'll have to choose both graphs, and then it'll say, okay, that's going to be your intersection point, and so it's going to be, that is your x and that is your y, and you want to round it to two decimal places, so your solution comes out 4.05 and negative 2.63. So again, once you have those entered into your y1 and y2, then you just have to hit graph on your calculator. This should pop up unless you have a really weird window. So then you have to change your window to maybe minus 20 to 20, or in this case, I did minus 10 to 10 and minus 10 to 10. And then after that, we just have to hit the second blue button and then trace, and then we hit number five. And then it's going to ask first curve, and then you just hit enter, hit second curve, hit enter, and then it'll say your best guess, and you just hit enter, and then it'll give you this solution that we show here. All right. Now, when these values are checked, the checks are sufficiently close, but because we rounded to two decimal places, they're not going to be exact. So when you plug them back in, those two numbers aren't going to be giving us the correct solution, but it's going to be pretty close. So that's why graphing is not the best as far as getting exact answers. All right, let's stop there and we'll come back for some more.